All right. We're going to get started here real shortly. So hopefully there's people logging in here as we speak. It's just turned 11 o'clock now. So we'll give it just a few more seconds to get rolling. For those of you that are on, appreciate you coming already. Just bear with us here as we kick this off. All right, Adam, should we get rolling already?
I think so, yeah. Let's jump right into this.
Okay, good. Well, so you're in the Waterjet webinar here, and we're going to cover the 5 most common waterjet questions that we very often hear in this industry and in this business. But more importantly, we're going to cover more than that. We want this to be a very live, interactive, chat room experience, and so that's really, really important. But like I said, we are going to cover the 5 most common things, and we'll weave in the live stuff as we go. So here's the key to this. Get ready for something different. So the live chat box over on the right-hand side of your screen, hopefully you see a chat icon or a chat box over there. Take a second, if you would, go over there and find that, because there's going to be a great experience here if we do this. Otherwise, you're just going to hear us talking about the 5 common questions. So figure out how to use that. Go take a look where that is. There's going to be live polls as we go as well. They're going to pop up on your screen as we click through these slides. We just ask you, just click really quick on the live poll. It'll be interactive and fun that way. And then we're going to try to weave in the live questions and answers piece as we go as well. So let me do some quick introductions on how this is going to go down. So on the phone with us, actually on the chat line with us, is Tim Fabian. Tim runs all the product development, product management, and marketing here at Flow for us globally. He's going to be typing as fast as he can. Hopefully you guys all blast him with lots of questions there. I see Tim just showed up on the chat line. So start interacting with him already. So let's start with this. Take a second, if you would, go to your chat comment line there and just tell us where you're from. Drop us a line on the country, the city, the state, whatever, just to kind of get the interaction started. I see Kyle says
Kyle
hello.
On there, yeah.
Okay.
And Howard. Okay.
So we've got a few people saying hello. Just tell us where you're from. While you're doing that, we'll do quick introductions on our ends. On our end, we mentioned Tim Fabian. I'm Brian Sherrick. So I've been with Flow for a little over 20 years. I manage our global systems sales team at Flow. So I'm the vice president of our global systems team. Super interested in the technology. Obviously, been around a long time. Can't wait to share some of this with you guys today, and again, jump over to your guys' questions as we go, so keep them coming. Adam?
Yeah, I'll jump in here. Adam Mooneyham. I'm based out of our headquarters in Kent, Washington. Been with Flow for a little over 15 years. Started out as an application specialist, training customers, a lot of software background with that. I now manage the Northwest region for Flow, for the business manager in the area, and I just saw it looks like we got somebody from Spokane on this call, so looking forward to this event here today.
We got Wisconsin, Illinois, Michigan, got Pennsylvania, so really cool.
Good. Nice collection of people.
Thanks for doing this, guys. This is going to be a lot of fun. We're going to try to keep this to less than an hour, or thereabouts an hour, depending on how this goes. So let's jump into it. So water jets, obviously that's what we're here to talk about. The line, if you can dream it, you can cut it. It's actually very true. It sounds like a big statement, but it's very true. We're going to talk about the versatility of the process today, and we're going to start from the very beginning. Adam can kick us off here with the water jet.
Yeah, absolutely. And I think this is, as we were kind of talking about our top 5 questions we often hear, I think this is specifically probably the question we hear most often, which is, are you really cutting with water? It's a big question, and as a water jet manufacturer, is often what we hear. And the answer is yes, absolutely. We're using high pressure water through a supersonic erosion process. So much like you see kind of the picture of the Grand Canyon there, that's really what we're doing, but at a much faster rate and a much faster speed to the process. And what we have here is a quick little video for the group and the audience, but showcasing just some of that, what's called a pure water jet. So not using any sort of additives or aggregate or any sort of abrasive in the mixture, but this is using that just pure water jet stream to do that soft material cutting. So this would be doing like a foam or a gasket or even like a soft plastic is what you can use for something like this here.
And there's a lot of good applications for pure water cutting, like Adam just said, from gaskets to foam, insulation, food. That's a very popular and great application for pure water cutting. That's very different.
Yeah, very.
Go ahead, Adam.
I was gonna say, I even got, I don't know if everybody on the screen can kind of see it here, so you can see what they're actually cutting. But again, a very soft material. The general rule of thumb is, if you can cut it with a razor blade or a knife, you can cut it water only with the water jet system. Then though, where there is the other alternative is using what's called abrasive in the mixture, which we'll be kind of showcasing next year on the machine.
All right, let me advance the slide here for us. Yeah, so Adam, you want to explain? So this, when we train the abrasive, it's a whole different game.
Yeah, exactly that. So in the early 80s, we developed what's called abrasive jet cutting. So this was using that garnet sand, typically is what you're going to be using through there, but taking that super high velocity of water, but now entraining that garnet sand in the cutting process. By doing that, we really opens up the doors and for a ton of other applications for water jets, getting into harder materials like your metals, the stone, kind of glass cutting applications is where you'd be using that garnet sand or that abrasive jet, as we often call it. We're really converting that pressure into velocity of that stream as it's traveling through. As we kind of jump ahead here, we have a quick little video for the group to kind of showcase just that, what an abrasive jet setup is here.
So you'll see it cutting through some carbon fiber material here. I think this is a chassis, right, Adam, that was made by Fireball?
Yeah, this was, I believe coming out of carbon fiber they had used for using that abrasive jet. And that moment you're seeing on the screen there is actually the piercing process for that part through the steps. But this is using a chassis on a little drone that they had developed with our customer over in Spokane, Washington, Fireball tool. And I think I see a question here. That's actually a really good question. I think we're going to get into some of that, but specifically kind of hard materials, what are available? The answer is kind of anything with the water jet, including some of your titaniums and Inconels and QT100 are great applications for water jets.
You can see that white line there coming out the bottom of that nozzle, and that's just slicing, slicing this material up. This material obviously cuts very quickly. As Howard just said, what's the hardest material? And like Adam said, everything will erode. It's a matter of how fast we can cut it, but you can cut any material type.
Yeah, and we'll get into the software, but typically you're going to program out that shape right on the jet and be able to process it and come right off the system as you're seeing. No secondary processing typically. We'll kind of jump ahead here.
Here's a good question from Jeff here.
So I'll kind of take this question here. So it looks like the question of, is aluminum oxide the only medium that our machines will typically use for the cutting? And then is that typically a one-time use, or can you use it again? The short answer is that actually aluminum oxide, although it can be used with the water jet, very uncommon, just because it's a very expensive material. It erodes the material very fast, but it costs a lot to buy it. Whereas more often we see a garnet sand being kind of used as that abrasive in the cutting process, just because it's a very affordable, readily available material as well. Regarding if it's multiple use or single use, again, it's typically a single use because a lot of that abrasive will be pulverized during the cutting process. So there's a very minimal amount of it that could be recovered to it, where it's not generally economical to go through that process of kind of reusing it. But I think a question for, I guess, the audience as well is what type of materials are you guys are going to be doing? And we're going to have a poll, should be showing up on your screen there, that kind of just get a good gauge for everybody in the audience here. What are you guys using? What are you seeing? What type of materials would you be cutting? Love to kind of get the feedback from the audience there. And
I'm looking at the results here as you guys are clicking. Just take a second, click on those different material types. Somebody's clicked steel already. Somebody's doing stone material, some aluminum. Yeah. Just want to get a feel for what you all are doing.
Yeah, it looks like a little bit of everything, I guess.
Yeah, it's interesting. The foam, rubber, and gasket, haven't seen an answer for that one yet. So, like, that's a pure water jet application. These others are all abrasive jet applications. So it's kind of interesting to see the percentages here. So yeah, finish up the poll if it's still on your screen. We'll kind of keep going as you're doing that. This slide here is basically just a picture of all these different random materials, and that's really the key to water jet, is it will cut everything. So you see glass shown there, and foam and stone, composites, steel and alloys. Aluminums are obviously popular. I would say the bulk of the water jet users in the marketplace are cutting metals, but glass and composites and stone and foam are also wonderful applications for an abrasive jet. A general rule of thumb, back to, I think it was Howard asked about hardest material. The harder something is to process or machine or cut traditionally, the better that application becomes for an abrasive water jet, because it's simply an erosion process. It's all speed related. In addition to versatility with different material types, you see in the middle there a very intricate shape, some sort of blade shape that was cut with 5-axis water jet. So very, very intricate shapes can be created with water jet. And then ultra thick materials can be cut. We'll show you a crazy picture of like a 24-inch thick piece of steel later. But again, it's erosion, it's speed related. The question becomes how fast and efficiently can you cut it, not can you cut it. So that's kind of the difference there. So here's another question that we wanted to cover for the group, and keep them coming on the live chat line there, because we want to jump to those too. You know, if you guys have better ones, more interesting ones for you guys. But the second one we hear all the time: how does your water jet compare to a laser, to a plasma, to an EDM? So we wanted to just touch on that really quickly. We'll run through a few slides, and before we do, there should be another poll popping up on your screen there. We want to know what type of equipment you guys are currently using in your shop. I'm going to kind of take a look at the poll here as you guys answer through these questions. I see a CNC, a laser, laser, and obviously EDM, there's more cutting processes than we have listed there. I see a bunch of you have water jets.
Yeah, I was going to say, it looks like.
It's interesting. A couple EDMs.
Huh. And this is, I think, pretty representative of what we hear in interactions with our customers. Is most customers kind of have a little bit of everything already. But
yeah,
yeah,
cool. Yeah, that's interesting to see those poll results. Okay, so let's compare the 4 different processes. So this is just a snapshot of the same shape, obviously cut by the 4 different processes. On the top left is the water jet. We'll look at that in more detail. On the top right, you can kind of see the laser edge. Just visually, you see a little bit of heat affected zone there. You can kind of see where it pierced in certain areas. So there is a heat affected area of that cut. On an EDM on the bottom right, obviously very high tolerance, high accurate wire cut part. And then on the bottom left, you see by far the most heat affected area, and probably potentially the fastest cut here, but maybe not the most accurate cut of the 4 processes, most heat affected area. So there's really these 4 major process improvements that you can kind of experience from water jet. So cutting into material, we've talked about. Cold cutting process, so we're not introducing heat or stress to whatever's being cut. A very satin smooth edge. It's rare, or not often do you see a secondary finish required to the water jet cut edge. Obviously, if you're going to machine a feature or something or bend the part, that's different. But I'm talking about the actual finished edge quality. And then minimal kerf. Minimal kerf allows you to cut very intricate parts, but it also can greatly reduce material cost if you're cutting high expensive alloys or composite materials where you want to maximize your sheet utilization there. So here's the quick close-up of the water jet part. Adam, you want to take them through?
Yeah, absolutely. Yeah, this is, I think, a really cool picture to see for a lot of our customers. It's just that zoomed in photo of this is a stainless steel part cut on one of our water jets. But as Brian was kind of mentioning there, again, we're not imparting any heat because we're really just that erosion process. So you don't get those heat affected zones or that hardening of the edge to it. And again, as a result, we get a generally considered a really smooth finish, which is going to range from that 80 to 125 RA finish on that. Again, you can dictate that, go to a faster edge quality with our parts and our software, but typically you see a very smooth finish on a part. And then as Brian kind of highlighted or alluded to, is for most operations, you typically don't need some sort of cleanup or secondary operation on that, where you get a finished part coming right off the water jet that you could use in your fabrication purpose.
Real quick, Adam. So yeah. Phil, another good question there. Appreciate you chiming in. You guys keep those questions coming, but can you cut hard and soft materials on the same water jet? It's a really good question. Yeah. And the answer is absolutely yes. There's some things you got to do to protect the surface of the materials or the bottom of the materials, depending on exactly what you're cutting, or to keep things as dry as possible. But the answer is absolutely yes, you can cut abrasive jet and water jet on the same machines often.
And one thing along those lines, and maybe this is to Phil's question, is to go from switching from even a hard material where you have an abrasive jet, like if you're cutting mild steel and then jumping to an aluminum or even a carbon fiber, is there any tooling changing that's required for that? And with our setup for our water jets is all you need to do is just simply in our software select what is the material type and thickness. So you don't have to change the flow rates of garnet, the pressure of the jet or the pump. That's all controlled right at our operator station.
So to kind of summarize this question about comparing waterjet to these other processes, we typically think of those other processes complementary. Honestly, they're really not a competitive process as much as a complementary process. And like Adam said, some of the most efficient shops that we've ever seen obviously have multiple processes that are really good at individual things. The cool thing about a waterjet is it's kind of good at all of them. You know, it can be a very good entry into a lot of other markets to help you explore other business opportunities. And then maybe you get some crazy high volumes and maybe one of those other processes helps you be as efficient as possible. If that makes sense.
Yeah. One thing to kind of, I guess, highlight with the waterjet, though, I think one of the big benefits for a lot of people in the fabrication world is although there are some great technologies with lasers, EDMs, and high-def plasmas, those are very focused kind of machine tools where they are very good at a select kind of bandwidth of materials or products that they might be cutting. Whereas a water jet, we're good at everything in some ways, where it can, no matter what you put underneath that cutting head, we'd be able to cut it and process your parts. Yeah. Oh, here. So it sounds like somebody logged in earlier, Donald. The question regarding stacking material. This is very unique to water jet technology as well, but the answer is yes, you can stack it with a water jet. So you can not only put multiple layers of the same material, you can also put different materials and cut it all at the same time. And a good picture there in the background kind of showcasing just that kind of stacking several layers thick of a material in process.
And you often see this in like sheet metal applications where you're cutting high volume of the same geometry out of a thin gauge material. It makes all the sense in the world to stack that up to get more efficiency out of the jet.
Yeah. I guess I'll kind of jump in here, but the third question we kind of heard pretty frequently is, how do I know what the right water pressure is for my business and application and what you're doing? And frankly, I think that's really what we're here for, to help, because there is no magic solution. We do build a variety of different pump styles, pump pressures, pump horsepowers, to really dictate that for each customer what the right fit might actually be for your budget, your application, your production needs to it. But it goes to the core is that the pump is really just that, the heart of a water jet system. So it's what's creating that high pressure water, creating that velocity of the stream is really done right at the pump technology, which is kind of shown here, a couple of the different pump models that you might see. And kind of just showcasing that, what you often hear in the water jet industry, in the water jet world, there's kind of two distinct ways to create that high pressure water. There's what's called direct drive or rotary style of a pump, and then there's what's called an intensifier style pump. Both will produce high pressure water. Both are great for the water jet world. It's just a matter, again, depending on each customer's needs and applications, would kind of dictate where you might fall within there. And then on the left, you see a little graph there showcasing some of the different pressures that are available. And those pressures are going to really range from about 55,000 PSI up to, on the high end, would be 94,000 PSI in the water jet world. And as we kind of jump to just showcasing a little bit of a spectrum of our entire line of different pumps that are available. And these can be equipped with multiple different machines and platforms, but you have what will range from our High-Plex Prime, which is on that 55,000 to 60,000 PSI pump. Then you have kind of the industry standard, what's been around for a long time, which is called the 60K Intensifier Pump. This will produce 60,000 PSI water right at the cutting head. And then the next evolution to that was what's called Hyperjet technology. This delivers up to 94,000 PSI of pressure at the cutting head using that Hyperjet technology. And we'll kind of jump specifically into kind of a few of these as we go showcase into the group there, how these pumps actually work and create that high pressure water.
Yeah, I'll jump in here, Adam, if you want. So Adam is talking about, direct drive and intensifier, two very different mechanical systems that will produce high pressure water. We want to get into kind of the details of that. Let's kind of start with the direct drive. So a direct drive pump, and you're going to see the mechanics of this, it's a rotary style pump. It uses a crankshaft to push three pistons through three cylinders, and you'll see that video in a second here. It makes up about 20% of the total global market share of water jet users. So the direct drive technology, we originally invented it because it actually outputs a lot of volume of water per horsepower of motor, and it's really good for surface preparation, paint removal, mining, industrial cleaning. We use that today a lot in those applications. So let's look at the details of it. Here's a good visual from a top-down view of this direct drive, also known as a triplex, because there's the three cylinders. You see the cam over there on the right-hand side, which is going to push those three little ceramic pistons. There's a video of this right here. So let's let this video play.
Yeah, so pretty cool rendering for you guys to kind of see what the kind of a cutaway of what this really looks like internally at the pump.
You'll see that cam rotating. Now this is obviously in slow motion here. This is usually 800 to 1500 RPMs, kind of depending on different variables, but that's pushing high pressure water out, and then on the backstroke, it's pulling low pressure water in. There's the check valve there. It's kind of close up view of that. Really cool pump. This is a pressure control valve system that'll allow any water that's not going to the cutting head to go,
to bypass automatically.
To bypass.
Yeah, and again, where that name comes from, it's a directly coupled electric motor to the cam or the crankshaft on there. So you get that very energy efficient design of a machine. And we can even jump to kind of some of those kind of main benefits that the technology offers.
This thing is still looping here. We'll go kind of summarize this for you. So the benefits of a direct drive. They're extremely electrically efficient. I alluded to that earlier, where they output a lot of volume of water for the horsepower of the motor itself. So that's a benefit in some instances. Compact in size. So if your size constraint is an issue, that's a benefit. Lower capital investment for sure versus the intensifier, which we're going to look at next. And then we make our direct drive with no additional cooling water needed. That's all part of a closed loop unit inside the Hyflex itself.
Yeah, very energy efficient. And this is just that. I was going to say that pump technology is what everybody kind of sees up close what that frame looks like. It does have a cover package on it, but this Hyflex Prime is what we call our direct drive. Typically well suited for our machines, which would be like our Mach 100 and 200 systems. Very cost effective, great technology. Again, kind of an ideal fit for those type of machines.
So let's now shift gears over to the intensifier style pump. Adam can kind of walk you through this a little bit, but I'll tell you, this is the most kind of common technology. It's been around for a long time, and it's an intensification principle. So you're going to see a hydraulic system instead of a rotary system. So it's a linear pump versus a rotary style pump. Let's take a look at it.
Yeah. And this does the same thing, this little kind of snapshot video of that pump framework. As we kind of go back here, and this will show that the top end assembly, which is the what we call the intensifier unit. So below that framework, though, is where the hydraulic motor will sit. But this, as you see on your screen, hopefully there is, you'll be able to see that cutaway of that intensifier unit. So that orange or kind of that yellow area on that's representing where the hydraulic oil would be. Inside of there, that large biscuit is attached to it, 2 ceramic plungers that are just simply stroking back and forth across there. There's on our 60K pump, there would be a 20-to-1 surface ratio difference between that inside biscuit to the outside plungers. As those are stroking back and forth here, that's what allowing us to create that 60,000 PSI water right out to the cutting head. And then with the Hyperjet technology works fundamentally the same way with it. That ratio does change to a higher ratio, so we get a higher pressure of water produced by the pump technology. And then as that water then travels out through the end of those check valves, it'll then go out to what's called an attenuator, which is a pressure collection device. And that will deliver that high pressure water right to the cutting head at a consistent amount and consistent speed to it.
So 2 totally different mechanical structures that both produce 60,000 to 94,000 pounds of water pressure.
Yeah. One thing to kind of point out, I know on the videos they're kind of hard to see, but the stroke rate on those pumps, with the intensifier, that is going to be about 60 to 70 strokes per minute, whereas with the direct drive style design of a pump, that's going to range from about 1,000 to 1,200 RPM. So there is a a fairly significant difference in the stroke rate of our two different pumps.
So in summary, the intensifier has its own benefits. The maintenance intervals are oftentimes longer in between seal changes on the intensifier than the direct drive. It's better suited to applications with a lot of on-off cycles. So that's kind of a particular nuance of an intensifier that is definitely a benefit. It's faster, a little simpler to rebuild those seals in there. There's less moving parts, fewer failures and downtime. And then it's not limited to the 60K pressure point, which is still totally applicable for certain things, but it'll go to 94K, the intensifier will.
Yeah.
So each one has its place, and we'll talk a little bit more about this.
And I think we actually got Howard had chimed in there about which pump is better if they both do the same thing. And a really good question there. And I don't think it's not necessarily a white or black question necessarily, because there's good pumps for each individual application and customer. And again, it depends on your cutting need in terms of how much you're going to run that machine, but also budgets do come into play as well as you're trying to discern what might be the best fit for your specific shop. And then that as you kind of see on the screen here is that Hyperjet. That's a picture of what that framework looks like. That is a fully mobile unit, so that's mounted on wheels. And again, this is typically well paired or well suited for our Mach 300, 500, even like our Mach 700 machines.
So now let's talk about the actual effects of pressure. So I know this is a big question because the pump is the heart of the whole unit, but we started with direct drive and intensifiers, looked at the mechanics of it. Now specifically the pressure. So Howard, your question about which pump is better if they do the same thing. Well, they don't necessarily do the same thing because the intensifier will go to that ultra high pressure of 94K. This is kind of the industry defined pressure levels. We focus on 60,000 PSI plus in the cutting environment of the waterjet world. So what does hyper pressure do? And frankly, the same thing is true when you go from 40,000 to 60,000 as it is from when you go from 60,000 to 90,000 PSI. Higher pressure produces more productivity. So it's faster cutting while using less abrasive particles in the cutting stream, which leads to a lower cost per part. Those are really the benefits, the physics of higher pressure. As we raise the pressure, the jet becomes more coherent and more efficient, and lower cost per part can be achieved. That's the benefit of that higher pressure specific part of this.
Yeah, I think I was gonna say we've got I think a really cool video that we had taken at our facility here of just running that same part with an identical setup. So in terms of edge quality, same thickness, same geometry of the part, and just simply running at a different pressure. So we ran one at the 60 kind of industry standard of 60K, and then the other at our 94,000 or 90K pressure, just to kind of what does that look like in terms of cycle time improvements to it with the higher pressure.
And keep in mind, this is irrelevant of what pump created that pressure. It's just comparing 60K versus 90K pressure. It doesn't matter if a direct drive created or intensifier. It's the effective pressure on cut speed. And then don't forget, the 90K system that won the race there used a lot less abrasive, and it cut it faster. So there's multitude of benefits to cutting at higher pressure.
Well, and that's a really good point, because specifically for like this, as simple as this kind of geometry is here that we're cutting for this part, that was, I think it was a little less than half a pound with our 94K pump, whereas at 60K, it was closer to about 3/4 of a pound. And again, depending on how much you're going to cut with the water jet, but if you're able to reduce your abrasive by that 20 to 30% reduction to it, that can represent a fairly significant savings in terms of your overall operational cost of the water jet, and then how many parts it can be produced in an hour at your shop.
Let's get
kind of skip it here.
Video here to go to the next one.
Yeah.
Okay, let's go on to question 4. So there was a lot covered there about pumps and pressures and whatnot. And again, keep your questions coming. Did I see a question about abrasive consumption somewhere?
I think I saw something about that.
Oh yeah. What do you do with the used garnet? It's an inert material. There's no hazardous waste created unless you're cutting lead or beryllium or something hazardous. But the parts per million of abrasive are usually so much higher than any heavy metals that it is landfill safe in most municipalities. So definitely got to check on that. It is typically not a major issue with the disposal side. But
a couple of things along those lines. I think that's a really good question because frankly, that's the headache of the water jet is trying to deal with that abrasive. There's a couple real simple solutions. Most customers will typically do that, take it to a landfill, either using like a vacuum truck or kind of just a suction cup to pull off the abrasive. But we do also offer abrasive removal systems that will automatically pull that spent abrasive out of your tank, put it into a separate hopper so you can dispose of it easy enough.
So let's go to question 4. Am I limited to the material type, thickness, or angles? The easy answer to that question is no, you're not limited. But the reality is there are some things you got to kind of account for and deal with when you're cutting with an abrasive water jet. And 2 of those specific things that need to be dealt with are taper and stream lag. And so the visual on the right-hand side kind of shows this diamond-shaped colored center section there. It's showing the taper. As it goes through the material, the jet loses energy as it travels through the material, and you can get a little bit of a V-shaped taper depending on exactly how fast you're traveling through that material. And we're going to show a video of this in a second. We've got ways to handle that. One traditional way, the old school way, is slow the machine down so that the jet remains perfectly vertical and the cut wall that I want to keep is perfectly vertical. Or we use technology and we eliminate that through dynamic water jet. We'll show you those things here in a second. The other variable that has to be accounted for is stream lag. So if you look at this little diagram, if you were moving from left to right across your screen, where the jet exits the material at the bottom is quite a ways behind where it enters at the top. And so that can affect the smoothness of your cut. It can have a visual effect and an accuracy effect, which needs to be accounted for too when you're talking about abrasive jet cut. So here's a video, and I think this really shows it as it goes through this piece of Lexan, I think is what it's cutting.
Yeah, I think we were cutting 1 inch thick maybe it's 2 inch thick Lexan.
Right now it's traveling pretty slowly, so you can see where it's exiting at the bottom is just a little bit behind where it's entering at the top. However, it's going to keep picking up speed. You can see that stream lag really starting to show at the bottom there. And now it's really starting to show because we're continuing to pick up speed as we go. And again, that is something you have to account for.
Yeah, and then that's what Brian's kind of highlighting there is that energy loss as you're traveling through the material, that power of erosion as you go through the end of that material starts to be less and less. And specifically what we had developed, this goes back probably about 15 years ago, a technology called dynamic water jet to address this exact issue and this specific problem. Whereas most job shops couldn't afford the ability to slow their cuts way down to get those perfectly vertical walls. What we developed was dynamic, and what that does is automatically adjust to account for that known amount of taper. And that known amount of taper is all developed by our modeling and our software for all of your different material types and thicknesses. But what it will do is it'll kind of dance around your part here with those extra 2 motors at the cutting head. They'll allow, we're not essentially eliminating taper. What we're really doing is just put it all into the scrap side of the part as well. So your scrap side will have all of that taper. Your finished part will be a perfect vertical wall across there.
Okay, so I need to see some more questions over there, everyone. We want to answer the stuff that you want to hear about too. We'll keep going here, but keep firing us questions. These are good.
And just so for the audience there, that material we're cutting, I think, was some kind of 3/8 aluminum on there on the machine, so you can see that. And then this gives everybody kind of hopefully a good kind of snapshot of all of the different cutting heads that are available with our water jets. So that's going to range from what's called a standard water jet or a conventional system. Again, what most people kind of think about water jets that have been around for 40 plus years is just a cutting head that's mounted in a fixed bracket. This will go just simply up and down on the Z-axis to it. Yeah, there, Brian's got a great visual to show you what that cutting head looks like. But again, that won't do any sort of compensation automatically for that taper. What we have next to that would be what's called our Pivot Plus cutting head.
And it's the same cutting head, but obviously it's mounted on a contraption that's going to articulate and move to eliminate some of the stuff we're talking about.
Yeah, and that's actually a really cool feature of how we design our machines is we want from our customers that have our highest end technology to kind of our conventional systems, you actually have the latest of the technologies. You can and then always retrofit it in the field as well. But going back to the Pivot Plus, that's going to be a full 5-axis system. This is kind of what in the water jet industry you'll hear about for beveling cutting and offering that 5-axis. That would be very similar to our Pivot Plus cutting head. The next evolution of that was what's called, like I mentioned earlier, was dynamic water jet. This is, again, that active taper compensation will adjust for up to 12 degrees to eliminate that known taper in your finished part. And then lastly, on the far right, you have, again, the latest evolution in the water jet world, but called dynamic XD. That's going to combine both the full 5-axis motion, up to 60 degrees of compensation, but then also integrated with our active taper models as well. So you have both taper compensation as well as the full 5-axis.
So really quick, good question just popped up.
Yeah.
Do all of these heads get rid of stream leg and taper? The answer is no. The one on the far left, the standard water jet, the kind of the old school, it's just mounted vertically. It's just dependent on how fast you're cutting. We're very proud of the fact that from Pivot Plus through Dynamic through XD, those all do taper compensation, as well as some of the 5-axis cutting in the Pivot Plus and the XD that Adam was describing. So while you're cutting at angles, it's very important to also compensate for that taper. So good question. Thanks for that.
Yeah, actually, really good question. Yeah.
Okay, what do we have here? We have another question.
Yeah, another
Danny.
question. Yeah. So the question is, do you have a machine or a system that's capable of holding within 1/1000th tolerance or better for cutting steel? And I guess the short answer is yes, we do. Yeah, we have technology, we have equipment that we can be well within that tolerance of 1/1000th. Certainly, that is on the kind of very tight tolerances in the water jet world. But with the proper setup, with the right technology, that is achievable, with the caveat of it depends on kind of what material, how thick you're doing. Sometimes if you're doing 1/4 inch versus 12-inch steel, yeah, those tolerances will change a little bit. But we also do have a full applications team here at our facility in Kent, Washington, where frankly that's really what they're here for, to help our customers in the field of, if you have a kind of a crazy application or something that might have a very tight tolerance like this, we can help you kind of walk through what the proper setup would be for something like that.
I want to sidetrack for a second too. A great question from Michael. What software is used for nesting parts? So our systems come with a complete software suite on them, and that's a big part of the machine tool itself. We build software that does the nesting for your parts, or we've got open architecture to where if you have a sophisticated nesting package already in your business, we'll show you how to import those into the Flowmaster suite and use those on the machine tool. So you can either come with it if you don't have it, or you can use an existing piece. But the software is a key factor in this whole thing.
I would agree with you. I think, yeah, as we look at what we call a water jet system, that's kind of broken up into a few main categories of the pump technology, the cutting heads, the actual tables themselves. But I think, frankly, the most important part of that is really the software package. And that's something we have what's called Flow Expert, our latest evolution to that software. It's a full solid model programming software that's available. So you can both integrate within other third-party software suites that you might be working with, or it is a full programming suite as well. And that's something we have the ability to send to any customers, kind of any demo seats of the software as well. So we'd be happy to kind of put you in touch with some of our applications guys for that.
And I see Jim, James, Michael, you got some really good questions, and some of those we're going to come back to in a second. Just to follow up, Michael, yeah, the offline programming part of that is the same kind of thing. The software suite has full CAD, CAM programming capabilities, or you can import already created CAD work. So quick question on the screen. There should be a poll has popped up here. Do you have a need to cut bevels or chamfers? So instead of just vertical 2-axis cutting, how many of you would need to do bevels and chamfers?
Yeah, I'd be actually really curious if this comes out to 50-50 or what this comes out looking like. So, because historically, I think kind of the bread and butter of what we see for our customers is a lot of water jet cutting historically has always been that vertical cuts, but we are seeing more and more customers gravitate towards that need for 5-axis and bevels and chamfered edges.
Yeah, but so far in the poll responses, like 80% of you are saying, yeah, you need to cut bevels and chamfers. And it's just interesting for those of us that have been in the business for a long time to see the kind of the evolution of this. Yeah. That's becoming extremely popular, almost common on machines now to be able to do the bevels and chamfer cutting. And a lot of that is software related. We've made the software to where it's easy to do now. You know, in the old days of waterjet, it was pretty tricky with an old CNC controller to try to figure out how to do all of that. So weld prep edges and beveling. Actually, let's show you some stuff here. We got some slides on the beveling. Adam,
well,
take them through the
specifically,
Pivot
yeah, I'll
Plus.
maybe jump to our Pivot Plus. Again, that's the kind of industry standard for what people think of for 5-axis cutting. This is configured with our Mach 200 machine configuration. But it does give you that 60 degrees of mobility and adjustment to that cutting head. So you can do those, like I think James was mentioning, weld prep to it. That's a great cutting head for design for specifically those type of applications. Like our other cutting heads, this does integrate our taper models to it. So even if you have parts that may be cutting out of like a 2-inch thick steel block a piece, we will be compensating for that taper within this cutting head too. And kind of jumping to the kind of a quick video here for the group to kind of see that Pivot Plus cutting head in action. We are seeing a lot of guys use it for specifically the stone world nowadays, especially with getting into harder porcelain and materials like Decton that historically are pretty tough to do with a saw blade. Using our water jet's a great fit for that, and this will provide those kind of mitered edges on your finished part. You can kind of see it dancing around this part here.
Yeah, and you see this a lot in the steel industry, like you said, for weld prep.
Yeah.
James. Actually, I think we have a picture of a part coming up that'll show a couple of different weld prep type edges that are pretty common.
Yeah, absolutely. And I think there was a question I just saw a little bit earlier about, is this hard to program? And I know we kind of touched on that a little bit, or to run the machine. Frankly, all we want your operators to know is what is the material and how thick it is. The machine handles all of the other aspects of the movement of it, the compensation, the turning of the wrist. That's all done right within our software. So we don't want you guys to have to get into any of that minutia of the machine operation. And you can see here it's kind of doing those 45-degree mitered edges on it. Do you want to jump in here, Brian?
Yeah. So you might ask, why is there a Pivot Plus and a Dynamic XD? And it's kind of like anything else. There's certain different levels. There's different investment levels as well, but depends on the performance you want. Our Dynamic XD is our most high performance, state-of-the-art cutting head that we make. It does the full taper compensation, full 5-axis, up to 60 degrees of angle cutting, and it's the most accurate, most robust cutting head we build. We typically put that on our Mach 500 platform. So it's just a matter of pairing the right technology to the right platforms for the right applications and budgets. So we make a wide variety of these, so they're kind of affordable for different industries and different applications.
And I think we've got some pictures of, so this was set up here at our Customer Technology Center here in Kent, Washington. We were cutting out some aluminum here with multiple different angles to it. And you can kind of see in the upper left quadrant of there, see what the fixturing was set up on our table. Our tables are designed to really allow for easy accommodation of individual parts. And if you want to pull out slats, they're all individual to it. And then like I can see if we get here, we set up a custom fixture plate. The bottom left corner, you can see kind of a close-up or a side view of that part. What's really cool for a lot of our customers that are looking at 5-axis is the ability to do like what's called a K-bevel on the part. And you can see that on the left side of that part is just that. That's actually processed in 3 individual cuts to that part. So you have your vertical, or I'm sorry, not your bevel on the top, then you have your vertical cut, and then your bottom bevel. That will process it automatically within our software, so we do that order correctly of it. But that's all controlled right at the machine. And then you could do the same thing on the right side of that, where you got 2 bevels that are meeting up to get that sharp point on there as well.
It's a good chance also, really quick, we get a lot of questions about fixturing with water jet. It's actually one of the kind of generic benefits of a water jet. There's very little fixturing usually required, and that's because there's very little stresses put into the material, either laterally or vertically. The jet is not pushing on the material. So in the top left corner, that's about as fancy as a fixturing gets. Pretty simple stuff where you're just kind of holding the piece in place. You're cutting in kind of a known coupon there, but typically a 1/4-inch piece of steel or something, you just lay it on the table and off you go.
And we have I think a video here of the this is that Dynamic XD cutting head in operation, so everybody can kind of see what that looks like. Again, as we kind of zoom in, this is a bigger sheet of material. I think this was about a 3-foot by 4-foot piece. And again, you don't have much fixturing required to set that up. And that is sitting right on those slats in the catcher tank as well.
What's interesting, if you watch this video, you'll see that little ring that's kind of riding on the material. It says on your screen there, it's called a compass. And what that device does is it monitors the height of how far the jet nozzle is from the material that it's cutting. And so as you get into angle cutting, you can see the part there finished. Obviously, the height at which we are standing off from the material becomes really important because I'm at an angle. If I'm strictly vertical, the distance I am from the material is not as critical. But anyway, that's what that compass device is. That comes on and off. It doesn't have to be on there all the time if you don't need it, and it's not a requirement for the part you're cutting.
Yeah, some customers, what they'll often do, I've kind of seen, is just that for parts that maybe require much more precision or accuracy to it, they'll pop that compass on. That's just a magnetic attachment to it. Great, simple tool. But other parts where you may not require it, they just pull it off their machine as well.
Maybe really quick, let's sidetrack. So a couple of great questions come in there about how do you accurately locate at a corner of the part when not just cutting. So I think what you're saying is you've already got the outside cut out and you want to locate features specifically inside that. The easiest way to do that, if I can explain this, simply, is you fixture and cut yourself a little L bracket, and you mount that to the table. You clamp that to the table. Then you put your material in that lower left corner, and everything becomes zeroed off of that lower left corner in that L bracket. If that doesn't make sense, ping us and I can try to explain it better, but it's a really simple thing to do. There's also technology that we supply that does laser location. So there's a laser edge finder that you can do some things that way as well. So
yeah. I've seen a lot of customers in the field do both of what Brian's talking about, but our laser edge finder, that'll just slide right over that mixing tube, and I'll show you exact location where that cutting head is. And then keep in mind as well, if you were going to be doing kind of you cut a part one time and then you're going to be possibly cutting it again 6 weeks down the road, you can save up to 10 different home positions in our software. So you can have a fixture plate just sitting on your table that you reference periodically and go back to.
The other good question I see on there is how do you deal with small parts? How do they not fall into the table? And like you said in your own question, micro tabs, little very small tabs that are drawn into the part, which is a standard feature in the software design part. That's a really good way to do it. Is just to put very small tabs in the actual part.
Yeah, and keep in mind, as the slats that are in the table, those are going to be 1 inch apart. So when we talk about smaller, if you did have some parts that are smaller than that 1 inch, you might want to consider that tabbing. We do often also see customers that may not require tabbing, but what they may do is just load up an entire sheet with hundreds of parts on it and then tab all those parts in. That way, from a processing standpoint, instead of actually pulling out the parts as you go along, you can actually pull out the entire sheet and then break them out later on, just to keep your machine kind of constantly running.
Yeah, you don't want you don't want to use your table as a load and unload zone. You want it to be cutting all the time. So that's a really good example.
Yeah.
Here's a quick snapshot of a variety of different platforms and machines that we build. Now we're kind of getting full circle here. So we've got the pumps, we've got all these cutting heads. Here's the different platforms. So starts at under $100,000 for your basic small envelope Mach 100, and then goes all the way up to your Mach 700. You see on their customized pricing, it's $1 million plus. You can get very large, huge gantries. Multiple gantries is another factor. If you look at that picture, you'll see 2 gantries on there, each with dual heads. So that's really a 4-headed machine in really big envelopes. Most popular platform is our Mach 500. That's kind of our flagship platform where we put all the different options on it. And then you see on the bottom right the NanoJet, the fully enclosed high accuracy machine. So huge price range, I understand, and we'll get you specifics depending on exactly what you want.
Yeah, and one thing, kind of make sure it's kind of clear to the audience there, is even though we build different platforms of machines, again, that Mach 100, 200, 300, and 500, within each of those platforms are available multiple different table sizes too. So we really want to kind of customize each machine with the cutting head, the pump, but also the table size to what your shop might be the best fit for what you're going to process.
I will say in the industry, and Michael, to your question about the table size, the bed size, 6.5 foot by 13 feet. In other words, 4 meters by 2 meters is the most common size platform that you see in most water jets. That's kind of your most common size configuration. However, that Mach 700, we can build that as long as you want, Michael. If you want it to be 150 feet long, that's just making the gantry rails on the tank as long as you want them on the ground. So there's really no limitation to the bed size. And real quick, lights out production. It's possible. There's lots of sensoring and ways to do that. We're working on a lot more ways to do that. So there's more exciting stuff coming with IoT and stuff, but definitely possible. But let's make sure we specifically understand the requirements there. We don't want to, over promote that idea.
And specifically on large tables there, I think to go back to, I think Michael's original question there was what I often see for our customers that do look for a large envelope. Pretty common platform for that would be like our 10 by 20 foot Mach 500 or even a Mach 700, just because that'll fit kind of a full mill sheet coming right out there as well. I guess the last of the questions that I think we were trying to, as we boiled this down to our top 5 questions, but what are the coolest things you've kind of seen cut on a water jet? I've had the fortune of kind of meeting hundreds of customers over the years, and I've seen some really cool stuff. But I think we got a couple photos. I think one of them that always stood out to me was a neat application is on the left side there's a customer cut some real thick stainless steel on the machine. So it was a 2 foot thick piece of steel. Certainly not the fastest cutting application in the world, but just a really neat to showcase the true capabilities of what a water jet can do as well. And then you get into, I think, the other question, going back to the earlier question about tabbing on it, but what we call micro cutting. So this is just that. If you're doing something that is a very small, detailed cutting, that same machine cutting a 24-inch thick piece of steel could then go process something as small as those little bicycles, about the size of a quarter to it. So just a neat to showcase the entire capabilities of what our water jets are designed to do.
And you see a lot of really cool to see food cutting applications. For example, chicken. There's a lot of chicken breasts that turn into chicken nuggets that are portioned by high pressure water jets. Tons of food applications, actually. So
yeah,
if you guys don't mind, type into the chat line any kind of cool application maybe you've seen over the years.
Yeah, I'd love to kind of hear from the group there of what you might be doing or seeing. Or I mean, we've got ranging from like what Brian's talking about, the food industry, to diapers and newspapers and drywall cutting. So just I've kind of seen a little bit of everything, but I'd love to see what you guys are kind of out there doing in the field.
Trying to think if there's another question over here, I think from Dave, about that laser locator that I mentioned. You says you use a Pazer system, use fixtures, and need to speed up the locating. That's definitely something that laser location tool could help you with. So we should follow up with you. I think we have your information, or if we don't, get back to you. Ping us again. We'll get you some specific information on that.
I see some asking about NASCARs, if we cut NASCARs. Yeah, we absolutely do. Yeah, Joe Gibbs Racing down in North Carolina, we work with really closely with. They use our water jets day in and day out at their production facility. Really cool technology what they're doing over there using the water jets. Again, what they're typically doing though is they're pre-processing them, like they're real thick or hard materials with the water jet, and then doing some sort of secondary machining for like the engine blocks and that kind of stuff.
There's a good question I see here. How difficult is it to cut glass and other brittle materials? The cutting of those materials isn't difficult at all. The only difficult part can be during the piercing. If you need to do an interior cut, you have to do it correctly. You either need to use our ultra pierce technology to get the abrasive in the stream so it pierces without breaking, or if you're cutting from the outside, it's no issue at all. You just start the jet off the material, it comes into the material, so it cuts beautifully, no issue. It's the piercing that you have to be aware of.
Yeah, and that ultra pierce tool, like I was talking about the cutting heads, as we develop new technology and make sure it's retrofittable in the field for our customers, that is one of those items that you can add on to your machine down the road if you started out as a metal shop and kind of doing those hard materials, but there's not a job that came around that you might be able to do composite cutting or glass, you can then simply add on our ultra pierce tool, which then will automatically get integrated within our flow cut module to use that ultra pierce tool.
I like Michael's question. Can the water jet cut the price of metal? Wouldn't that be nice?
Yeah.
Yeah, if you buy a flow water jet, your metal prices go way down, Michael. Yeah.
Although one caveat to that, realistically, one benefit to the water jet technology, again, because not using any heat in the process, what we can actually get is near net shape cutting. So we can help optimize your material. So if you can do parts that are much closer together, And we also do offer within our nesting program is common line cutting. So for specific features or geometries, if you're going to be doing like a square bracket, we'll use that common line tool to really reduce any of that excess waste of material to your part.
James just asked a great question, software related. Does the software prepare a drop DXF for future processing of skeleton sheets? And absolutely it does. So we call that remnant nesting. So it'll save the unique, odd DXF shape of the good material that's left after a nest that you can then future nest on automatically. So
yeah, you'll save that in the directory of the software and then pull that remnant down the road. Yeah, it's a good way to kind of optimize that.
Yep. So as we continue to go through these questions, anyone else, just keep firing them out. But to get more detailed info from us, on the screen right now is obviously the phone number. You got Marie's email address there. We would be happy to do test cutting, get you machine quotations, do specific software demos, which are really easy to do virtually now. We finally got our act together with Microsoft Teams, so we can show you all about the software and remnant nesting and things like that, James. So make sure and reach out to us if we can help you at all for anything.
Yeah, and a big part of that, at least certainly here for the Northwest, but we are still hosting customers in a COVID-safe environment to it. So customers that do want to come out and see a machine in person, get your hands on that, we'd love to host you here, walk you through both the software, the cutting heads, the pumps. But we're all, like Brian mentioned, doing those virtually as well. And then we do have regional, obviously, teams and support people that are around not only just North America, but around the globe as well.
Yeah, I see somebody mentioned, Howard mentioned the Waterjet channel. I don't know how many of you guys have seen them on YouTube. They do some weird, wild, crazy stuff with their Flow Waterjet. Pretty entertaining if you're into the kind of the goofy side of things. But yeah, that's a good way to see a lot of Waterjet stuff. Fireball Tool also has a YouTube channel where they do a really good job explaining how their machines work, and they do some pretty cool Waterjet videos as well. What else is on here? Oh, how do I get a test cut?
Yeah.
Just contact us. Either shoot Marie an email here or call that phone number, and we'll have an applications person get a hold of you right away and get you some test cuts done.
Yeah, and as well as we'll be sending out a follow-up email to the group and everybody that was able to attend. You'll be able to download and kind of watch the video again if there's any questions we answer during it. But as well, you can respond to that, and we put you in touch with our local team wherever you might be located at, and kind of go see how we could be of help there for you.
Well, with that, I think we've hopefully answered some of your questions, and it's been entertaining. It's been really fun for us to have a kind of a live dialogue with you. Can't wait to do this in person at trade shows and in your shops someday again, hopefully sooner than later. So thank you so much for joining, and we'll talk to you all soon.
Thank you very much.
All right.